We can use matrices and the calculator to help us solve systems of 3 equations and 3 unknowns fairly easily. Let's take a look at this example. At the concession stand, Matthew bought 2 bags of chips, 1 candy, and 2 drinks. He spent $3.80. Lauren bought 1 bag of chips, 1 candy, and 2 drinks. She spent $3.05. Alicia bought 1 bag of chips and 1 drink. She spent $1.60. How much does each item cost? Well, first let's set up what our variables will stand for. Let X be cost of chips, Y equals cost of candy, and Z equals cost of drinks. And then we'll set up our system of equations. So for Matthew bought two bags of chips, so 2x plus 1 candy, so plus 1y, plus 2 drinks plus 2z, and that cost $3.80. Lauren bought 1 bag of chips, so that's 1x, plus 1 candy, that's 1y, plus 2 drinks, that's 2z, and that's 3.05. Alicia bought 1 bag of chips, that's 1x, no candy, so that's 0y, and I am going to go ahead and put the 0 in there because we're going to need it as a in our matrix when we set up our matrix, plus 1 drink, so plus 1z equals 1.60. So now I have a system of equations and 3 unknowns. Now this system of equations is the same as the matrix equation that we would get by putting the coefficients of our variables here, 2, 1, 2, 1, 1, 2, 1, 0, 1, and multiplying that by the matrix x, y, z. And if you think about it, the reason why this right here is the same as this is when you multiply matrices, you multiply a row times a column. So if I multiply 2, 1, 2 times x, y, z, I get 2 times x, 2x, plus 1 times y, 1y, plus 2 times z, plus 2z. And then for my next one, 1, 1, 2, 1 times x, 1x, 1 times y, 1y, 2 times z, 2z. So this product here, this matrix product, is the same as this side of this system of equations. Well, when I multiply that all out, I would like to get the matrix 3.80, 3.05, 1.60. Now, to solve a matrix equation, I want to figure out what x, y, and z are. So I want to get this matrix x, y, z by itself. So I want to get rid of this matrix. To get rid of this matrix, I multiply by its inverse. So I'm going to take 2, 1, 1, 1, 1, 0, 2, 2, 1 inverse multiplied by 2, 1, 2, 1, 1, 2, 1, 0, 1 times x, y, z. Sorry, my 2's and z's are identical, but that's just how they are. Now notice I multiplied by the inverse matrix in front, and so I have to multiply by the inverse matrix in front here because matrix multiplication is not commutative. So I'm going to multiply this by 2, 1, 2, 1, 1, 2, 1, 0, 1 inverse times 3.80, 3.05, 1.60. Okay, now I'm going to put these matrices into my calculator. So let's see. Okay, so I'm going to put this matrix into matrix A and this matrix into matrix B. So second matrix, edit. It's a 3 by 3 matrix. And my values are 2, 1, 2, 1, 1, 2, 1, 0, 1. Okay, so there's my first matrix. Now let's put in our second matrix. Whoops, let me mess that up. So this one, 3, row 3, column 3 is supposed to be 1, Make sure that's right. Enter. It is. Okay, so second quit. Now, second matrix, edit, matrix B. This is also a 3 by 3 matrix. No, it is not a 3 by 3 matrix. It's got 3 rows, 1, 2, 3, and 1 column. It's a 3 by 1 matrix with the values 3.8, 3.05, and 1.6. Now I'll go back to my home screen, and I'm going to take matrix A inverse, that's this, times matrix B, and there's my answer. So 0.75, 0.6, 0.85. 0.75, 0.6, 0.85. Okay, so there's my answer matrix. So that tells me X is 0.75, so that's the cost of chips. So chips, 75 cents. Candy, that's this one, 60 cents. And drink, 85 cents. And by the way, that's where they make all the profit, just in case you were wondering, because it doesn't cost a whole lot for them to get the drinks, and that's where all the profit's coming from. Let's take a look at another example. Let's say we had 3 people who went out for sushi. David got 2 shrimp rolls, 1 tuna roll, and 1 drink for $21.25. Lisa got 1 shrimp roll, 1 tuna roll, 2 drinks for $16.75. Kristen got 2 shrimp rolls and 1 drink for $15. So let's let X equal the cost of a shrimp roll, Y equals the cost of the tuna, and Z equals the cost of the drink. Then from David, we had 2x plus 1y plus 1z equals 21.25. From Lisa, we have 1x, 1 shrimp roll, so that's 1x, plus 1 tuna roll, so that's 1y, plus 2 drinks, so that's 2z, equals 16.75. And from Kristen, we have 2 shrimp rolls, so that's 2x, no tuna rolls, so plus 0y. I put that 0 in there because I'm going to want to have the 0 in my matrix, plus 2 drinks, so plus 2z, equals $15. This system of equations is the same as if I write the matrix 2, 1, 1, 1, 1, 2, 2, 0, 2 times the matrix x, y, z equals the matrix 21.25, 16.75, 15.00. Now to solve this, x, y, z will equal 2, 1, 1, 1, 1, 2, 2, 0, 2 inverse times 21, 25, 16, 75, 15, 0. Okay, so I'll edit my matrices. Matrix A, edit it. Let's see, it was 2, 1, 1. That's the same there. 1, 1, 2, that's also the same. Similar in concession stands and sushi buying habits. And then 2, 0, 2. Make sure we have that right. So it was 2, 1, 1, 1, 1, 2, 2, 0, 2. Alright. Okay, now let's edit matrix B. Sushi is a little more expensive than chips and candy at the concession stand. We'll have 21, 25, 16, 75, and 15. Go back to my home screen. I still want to take inverse of matrix A times matrix B. I can just do second answer to call up the last line that I did here. I've changed my values of A and B, so I should end up with the right numbers here. That a shrimp roll is $4.50, a tuna roll is $6.25, and a drink is $3. Now, if that's just iced tea or Diet Coke, then again, that's where I'm telling you they're making all their money. So $4.50, $6.25, and $3. So that's our answer, and so the shrimp roll cost is $4.50, tuna roll $6.25, and drink $3.